So everyone by now has heard of OpenAPI. If they haven't, they've heard of Swagger, and OpenAPI is the new name for Swagger. So it's used to describe the capabilities of web APIs, and that allows both humans and computers to understand a service. And that's kind of a weird way to put it, but when computers understand a service, they can generate documentation and client code, which makes it easier for humans to understand the service, right? So that's how we're going to use OpenAPI today. Now, when we work with OpenAPI, you're typically going to work with some kind of tool, such as Swagger, NSwag, or Swashbuckle. The tool that we prefer is NSwag, just because it provides an end-to-end experience. And that means that based on a web API you've created, it can generate an OpenAPI specification, and then it can use that specification to generate a Swagger UI interface, which we'll see, and to generate clients, such as a TypeScript client for your Angular front end, or a C# client, maybe in the case of a microservices architecture. So we'll have a look at that. So we're not going to talk about single page applications, we've already covered that. We're not going to do that. We are going to have a look at an implementation in the single page application and what's wrong with it to start with. So you can see in the application, when you go .NET New Angular, or you go .NET New React, it comes with a sample, and it's essentially a fetch data sample that returns a list of weather forecasts. So if we come in and have a look at this sample here in the Angular implementation, we can see that we get that out of the box, okay? So you can see this for yourself. And essentially what it does is it goes in, it grabs data from the server and displays it on a page. So it's very simple, but even in this 23 lines of code, there are 4 things wrong with it that we can fix just by leveraging OpenAPI. So let's have a look at how that works. So in this sample, the front end has a fetch data component, which we saw, and the back end has a weather forecast controller. I think they've actually renamed that to sample data controller now. So the front end makes a request for the weather forecast, and the back end responds with the weather forecast. Pretty simple. The code looks like this, and you can see here that we're using Angular's HTTP client to make that request. We're saying we want a collection of weather forecasts. We're specifying the URL where we can find the API endpoint, which will return that collection of weather forecasts. We're then taking the result and assigning it to a property. We also have this DTO on the client side, which is actually a duplication of DTO on the back end, okay? So we've got 2 versions of this, so that's a violation of dry. So the problems are that the developer needs to know about this API. They need to know kind of the actions that are available, and they need to know the endpoint, you know, so because they've hard-coded this URL. There's duplication of backend types, and breaking changes are hard to detect. For example, if I change kind of the name of the action on the server side, we're not going to see that here straight away. And there's a way that we can have that behavior so that we do see it immediately. So what we're going to do now is implement OpenAPI. So we're going to do 3 things. We're going to automatically generate an OpenAPI specification. We're going to take a look at Swagger UI and how that can be useful. And then we're going to generate a TypeScript client. 4 things. And then we'll refactor that sample data, kind of fetch data component, so we can see how we fix those 4 issues. Let me get set up. First, I think we'll launch the application. Now, one of the things that I like to do with the single page application templates is just modify the way the application starts. And you do that in startup.cs. If we come right down to the bottom here, you can see that by default, it just has use Angular CLI server, and it runs an npm script called start. What I prefer to do is to not have it automatically start the Angular CLI server for me, and so instead we say spar.useProxy to spar development server. And that's because when you start them both together, the startup process takes a long time. It can take 10, 15 seconds. And if we make a change to the back end, then that means to relaunch the application, have a look at that running, it's 10 to 15 seconds. Whereas if we take that away and just let Angular be hosted by itself and .NET Core be hosted by itself, then it's just a couple of seconds, if that. And so we'll have a look at that now. So I like to do this demo actually in VS Code just for something different. So I've got my cheat sheet handy, so that'll help. Let's see, we'll go back. Want to go into our SPA folder, our web UI folder, and we need to start the back end and the front end separately now. So if we go into client app, we can run npm start, and that's what we were doing in startup.cs, but we've changed it so we don't have to do that now. So we'll let that start, and we'll come back and check on that. And I also want to start the back end from the command line, and I can go .NET run. Sorry, I want to go .NET watch run. I want it to keep detecting those changes as I make them. Into awesome SPA. There we go. Okay, so this is running slowly. My Surface Book. My Surface Book's getting on in years now. It's time for an upgrade. So that's the Angular front end. So you can see it takes quite a while to start. So the back end's already started, but the Angular's still going. There we go. So they're both up and running. So let's go to that page. So we can see here we can hit 5001. So we'll do that. Cool. So that's the basic template you get out of the box. And what we're going to be looking at today is this fetch data component. So you can see when you're creating a single page app, you get this sample of a static component, which just has some static data, a sample of a simple example of a component that just increments a number, and then we get an example of a component that communicates with the backend server. One of the things that's cool is if I make a change to, I'll just open this client code. We'll open the lot. I'll open this with code. If we make a change, say, to our counter component, because currently it's incrementing by 1, which is rookie numbers, we're going to increment by 1,000. That's going to be detected automatically by Angular, and we're actually going to be able to see that change on the front end as soon as it loads. We didn't do anything. We didn't refresh or anything there. That's just happening. It's just part of the build process. So that's nice. And so we're going to see this same kind of example when we refactor this weather forecast. Because we've got .NET Watch running on the back end, if we make a back end change, that's gonna happen automatically too. So if I just contract that and go to controllers and go to our weather forecast controller, and currently it's returning 5 items, but I'll change it to 10. Save that. And you can see it detected the change here in our backend process, and it's starting Kestrel and it's running again and it's ready. This is refreshing, and so now instead of returning 5 items, it's returning 10 items. So it gives us a really nice development flow. We don't have to do much. We can just write our code, and those processes will keep ticking in the background. And it's really those processes that we're going to leverage once we set up OpenAPI to make breaking changes easy to detect. So let's do that. Oops. I have a different set of keyboard shortcuts now. So the first thing we're going to do is to install the nswag components that we're going to use. So I've got my command prompt here, and we'll go .NET add package nswag.asp.NET Core. So that's the package that we'll use to generate the OpenAPI specification and to expose Swagger UI. And then on this side, we're also going to install for later nswag.msbuild, and we're going to use that to automate the entire process so that once we get this right, we don't have to touch it again. There we go. So that's done. I would actually like to restart Angular CLI in Visual Studio Code, because when we run it through there and it detects an error, you can click the link and it'll take you to the code file, which is quite nice. So we'll do that just quickly. npm start is what we ran, and we'll make that smaller. Okay, so we've got the packages installed, and now we want to update startup.cs. Yeah. So I'll use my cheat sheet so I don't have to remember everything. So this first section is going to add an open API document, and it's going to have the title Awesome Spa API. And that is in startup.cs. I'll just hide the terminal if I can a little bit more. So we want to say using nswag.ASP.NET Core. And we can add this just after static files or wherever we want, really. Let's try to clean that up. Well, cleaning up very nicely, there we go. And then we also have this one, which we can add here just before routing. Indent that a little bit. And that's saying, okay, use Swagger UI, expose it here. So you remember we looked at health checks and we would navigate by going to /health. Well, we're going to access Swagger UI by going to /API. Most people would do it Swagger, but I like to do it this way. And then we're going to have the OpenAPI specification actually stored in a static file in www API specification.json. So we actually have to generate that now. So I'll just save those changes. And what I'm going to use now to generate the specification, kind of to generate also the configuration for NSWAG, is NSWAG Studio. So if I launch NSWAG Studio, this is unfortunately a Windows-only tool. So if you're running on a Mac, that's okay, because I know a lot of Mac users have Windows on the flip side, so you just flip over and launch NSWAG Studio from there. Is that right?
Yeah.
Okay.
Or you just get someone on your team you use this to make a config file,
yes.
And then that config file ships everywhere anyway.
Yeah, we'll check it in, so then good to go. You'll still need .NET Core. That'll be probably the only thing. I only say that because I have a friend who's like, yeah, but how can I do it without .NET Core? And I'm like, I don't think I even care. So not very nice, but that's okay. So we're going to create, I'll close that, whatever that is, and create a new file here in NSWAG Studio. And basically we're creating a configuration file. So when I go new file, that's what we're doing. So I'm going to zoom in so we can see this. So we're going to create an input, an OpenAPI Swagger specification. So OpenAPI /Swagger. And what we're saying here is that we want to generate a new specification based on something. This is for .NET Core 3, so we select .NET Core 3. And we're going to generate it using the ASP.NET Core via API Explorer, which provides really good functionality for working with OpenAPI. And instead of selecting an assembly, we're going to select a project. And so we just navigate to our Awesome Spa project. Zoom out a bit there. So there's our CS proj file. Zooming back in. So scrolling down. We're going to integrate this into MS Build later, so I don't want it to actually build as part of generating the specification, because then it would build twice. And it says here, use document provider. It's the default choice, and that's why we needed to go and configure startup initially, because it's going to be looking for this when it generates the specification. So just to recap, excuse me, I set the runtime to .NET Core 3. I browsed to the CS proj for our web project. I set no build equal to true. I left this as a default choice, and I'm going to set an output path. Now remember, I said I wanted to place it. I'll grab this because that will save some effort. I wanted to place it in www. So is this the right one? Yeah, that's the right one. So www, and I'll create a new folder called API, and I'll call it specification.json. Now that that's done, we can actually test it, and we can test it just by clicking Generate Outputs. And that worked. I didn't have to build because, we've got .NET watch run ticking over in the background. So this is the Open API specification, and this is what makes it easy for computers to understand our service. So you can see it's describing the operations and inputs and outputs for everything in our awesome Spa API. I'm not going to go into details, but I do want to show you one thing. It's describing our DTOs in this document as well. So if we've got view models, DTOs, hopefully not entities, as we do in this simple example, they're going to be described in the Open API document as well, and that's what we can use to generate those types on the client side, so that we don't have to duplicate those types. So that's really important. We'll see that. So now I want to save this configuration, because we're going to, as I've mentioned, we're going to actually automate it using an MS build later. And I'm going to save it as nswag.json. And the reason that I call it nswag.json is because nswag has a convention. If you name the configuration file nswag.json, it'll find it automatically. So it's just a little bit simpler, right? That's the thing with conventions-based framework. If you know the conventions, it makes you more productive. You can do things much easier.
Yes, just to repeat that, there was two configuration files going on. The specification.json, that is generated from your API, it's going through all your controllers, all your actions, looking at what events are on there, and then also looks at your DTOs, your objects, and puts them all in a specification file. The nswag.json is all about the configuration of how that was built. So it's saving the configuration for nswag from your nswag studio, putting it on disk, and we're going to use that later to automate the process of building specification files from our running application, or from our application code.
Yeah. Okay, so let's try and access it now. Should work. So what we're trying to access is Swagger UI. The specification's in place. Is it? No, the specification's not in place. So we've seen that it works. Now we have to click Generate Files. And that's going to put that specification in place. And I want to see, doesn't detect that, but let's have a look at it just so we can be sure. So it's in www-root API specification. So yeah, we can see that it's been created in our project structure now. So hopefully we can reference it when we go like that, and we can. So this is one of the things that makes it easier for humans to understand your API, right? We've generated documentation automatically for our API really just by clicking buttons and selecting options. So we can see there's a to-do items option and a weather forecast option. So those correlate to our controllers. So we've got get to-do items, post to-do items, get to-do item by ID, put and delete. And what's more is we can go and try these things out now. So if we click execute, we can get back a list of to-do items. Oh, there they are. And we can download that JSON file as well. So if we had some need for that JSON, such as maybe feeding data into a test or something, we can do that. So we can use this to explore our API, to understand our API without having to look through the source code or even have access to the source code. So that's kind of cool. We can also try things out. So, here's a get by ID. We can try that out. Maybe someone's reported an issue, or we're just trying to understand the service a little bit better. It just provides us with a really nice UI to access that sort of thing. Obviously, this API is not authenticated, and authorization isn't required. But in the case where it is, take a look at the clean architecture sample, because I expose a way to basically add your access token so that you can continue to run these requests. And that's an important point. This Swagger UI isn't like a backdoor to your application. It doesn't provide you with any access you didn't already have. It just provides you a different way of accessing it. And so we can start to have a look at this before we even have our UI built, which is great. So we've got Swagger UI. Why don't we generate a TypeScript client to go with our Angular app and refactor that component to get rid of all the problems. So to do that, we come over here and we click TypeScript client. You can see we can also generate C# clients and C# controllers. We'll focus on this one.
Yeah, so far we've generated a bunch of server-side stuff. We've got our code we've written. we've generated a specification, and from that specification we can generate that nice UI to let us browse our application. Now we're going a step further and actually generating code to talk to our our app for us.
So we don't have to write that code ourselves, right?
No.
Okay, so we're choosing a TypeScript client. We're going to use TypeScript version 2.7, and the template we're going to use is actually not fetch. You can see there's a whole bunch of templates we can choose from. We're going to use an Angular template.
There's 2 people that are very happy with the Aurelia option.
Yeah. Everyone that uses Aurelia. No, there's 14 people. That is mean. There's 14.
No, that's mean.
Does anyone here use Aurelia? No. Okay.
Yeah, there's somewhere else.
Yeah. So we've selected the Angular template, so it's going to generate an Angular client for us, or an Angular service. We're programming against RxJS version 6. We're going to use the Angular 6 singleton provider because that makes our life easier. Don't worry if you don't understand some of these Angular terms. We're going to use the injection token. We'll leave the defaults there. We're going to generate interfaces for our client classes. Not because we use those interfaces in Angular, just because it provides us with a pretty table of contents, really. And I'll show you that. Let's see, DTO types. I like the interface style. Wait a sec. Did I click on something wrong there? I think I did. There we go. And we want to set the output, okay? So we're going to generate this TypeScript file and place it into our Angular app. And you watch, our Angular app will see it straight away and start ticking over and actually, check it and make sure that it's all good. So there's our awesome API.TypeScript. So we'll save that. We'll go over to here. Detect it. Hopefully it detected it. Let me see if it's been... Oh yeah, sorry. Forgot to do it again. Now we go generate files. But first we can go generate outputs to see if it worked. Yep, it worked. That's great. So you see we have that pretty table of contents I promised. So we've got an to-do items client, and it tells us all about the methods that are available on the to-do items controller. And then we've got the implementation, which is all very nicely written TypeScript and Angular. We don't have to write ourselves, which we did have to do in the past. And it certainly does a better job than we did. And then we have our weather forecast client with its one option. And then we have all of our types that we're exposing via the API. I probably said it before and I'll say it again, we shouldn't be exposing these entities, but it does provide for a nice simple example. And of course, when you look at the clean architecture sample, it's using DTOs and view models as it should. But these are no longer duplicated. Okay, so that worked. So now we're going to generate the files, and that'll put the new API into our project. Should see that shortly. Yep, there it is. Is it detecting it? Maybe because I'm not using it? We'll forge ahead anyway. I think it'll be fine. So I'll hide that. Now I want to, can I do that? Yeah, good, that's better. So now I want to update the fetch data component. So Control P, fetch data component, and we're basically going to clean it up. We don't need this from Angular Core anymore. We don't need the HTTP client, so we can delete that. We're not going to inject all this stuff into the constructor. We're not going to need to access that endpoint in that way. We're not going to need this DTO anymore, so we can delete that too. Nice and simple. So now what we actually need is just that client that we generated. So we can say, what was it, the sample data client?
We call it API client, did we, or what do we call it?
Let me check. It's awesome API, and it's a weather forecast client, I think.
That's right.
Weather forecast client, there it is, that's great. We can say client.get, that's done. Doesn't know what the weather forecast type is. But we can fix that, control period, add it from the generated code, and that's it. Like, save the changes, watching Angular tick over and see all that happening. Go into our front end, see if it still works. Fetching some data. Looks good. All right. So pretty simple now. And this is a simple application, but that sort of code is going to appear everywhere in a large application, especially if you start, kind of generating those, not generating those DTOs and view models. So it's a big time saver. So one last thing we want to do is just to automate that process. We're done with NSWAG Studio, so we just need to save our configuration. So that'll save the nswag.json file. Close that and go to my cheat sheet. And you can get this at the NSWAG documentation, but essentially we're going to create an MS build task and add it to the CS project of our web project. And I'll describe it for you. Where is it? Here. Hide that. Or you can put it anywhere really, but. So you can see we have a task that's going to run after build, and it's only going to run when we're in development mode. And the reason for that is because I check these files in. I check in the specification, I check in the generated code. I don't want to really deal with building it as part of my build pipeline. I don't need to do that. I can do it at development time. So you can see that it's referencing nswag exe on disk, which is running version 3, .NET Core version 3, and it's saying run, and this is equivalent to essentially nswag run, and what it will do is it will find the nswag.json. We don't need to specify that, okay? And so that's pretty much it. Why don't I run that so you can see it? I don't need to. There we go. So that's what would happen if we ran nswag.run from the command line, but it's kind of complaining about the version of .NET Core that we're using. So I'll just check on that. Okay, so we can do a couple of things. We can go .NET version, and it's 3, so that's good. We'll do a quick build and make sure we have no problems there, because our nswag's going to look at that project.
There you go, execute for nswag.
Yeah. So it's launching. It's actually launched that build task as well. So after build, it runs nswag. Let me try that again. Nswag run. It's probably because the pathing of the nswag that I'm referencing is the wrong one. So we'd have to dig in a little bit and see which one. I can't quite remember where it's stored either. Do you know where it's stored, the different versions?
I'm not sure.
Let me try one thing.
That was working from the build where you needed to. It was just the command line that wasn't wired up properly.
Which is the purpose of the demo, but I decided to go rogue and that's okay. Let's have a quick look though. Yeah, no, I don't know. I'm not going to dig in too much. I'm happy that if I run .NET watch run, that it's going to keep building my backend, and if I change something in the web UI, it's also going to kick off those nswag processes, and so those changes will be reflected immediately. So the last thing that I want to show you is now breaking changes are easy to detect. So if I load up this fetch data component, right now the endpoint is called get, but I can easily change that. So if I go to the weather forecast controller and we specify the route to be slightly different, we say the route should be the name of the action, and we say change it to get weather forecast. Not a very sinister change, but definitely a breaking change. If we save those changes, we've got our backend here has detected the change. It's restarting Kestrel, and you don't see it, but it's also running that MS build task that we created. And so that's finished. Then over here on the front end, it's also going to rebuild the Angular app. And the reason for that is because it regenerated awesome API.TypeScript. Angular detected that change, rebuilt that, and now it's seeing, oh, there's an error. So I can actually control click on, oh wait, that's not, yeah, that's right. Normally I can control click on that, but that doesn't matter. What I can do is hide that and go to my fetch data component, and I can immediately see that there's an error. So not only is there an Angular CI build error, there's also a squiggly under this. Now, as a developer, I don't actually need to know what's happened here. I don't need to understand the API. I can just go dot, because I have a client now that's been generated that basically describes itself. So that's pretty cool. So we save that, and everything could be happy again. And yeah, compiled successfully, working on the front end. That's it. So let's recap a little bit on what we did. So we had this fetch data component, we refactored it. We're now bringing in generated client and a generated DTO. It's much easier for us to query that front end. We can just go client.weatherforecast or client.get, as in the new example. And we can explore the API endpoints. Developers have an easy way to do this. They can either do it using the generated client, they can do it using Swagger UI. Like the API is self-documenting now. We don't have any more hard-coded URLs, so we don't have to worry about that issue. We don't have any duplication of backend types. That's been fixed, they're generated. And our breaking changes are now easy to detect, which is amazing. It's a really nice development experience, especially when you take into account, you know, .NET Watch Run and Angular or React's capabilities with its build systems, and the fact that TypeScript is able to pick up, the fact that VS Code picks up those errors so nicely and shows us what's wrong. So I've got some recommended resources, pretty simple resources there. Learn more about OpenAPI at the official page. NSWAG plus ASP.NET Core, if you want to get up and run quickly, that's the Microsoft Docs. So you can have a quick look through it and kind of get started in a very simple way. When you need to learn more about NSWAG, as you will, head over to the NSWAG docs, check out the documentation. If there's something not there, make sure you have a search through the old issues, and if you still can't find what you're looking for, then raise a new issue. The guy who builds this, Rico, is very responsive and helpful. So key points: generate OpenAPI specifications because they make our life easy. Documentation for developers through Swagger UI or generated clients. We get Swagger UI to interact with our API endpoints so we can troubleshoot and explore and just learn. Automatic generation of API clients. We saw it generating a TypeScript client, and we saw that there was plenty of other options for our different use cases. And my recommendation is to use NSWAG because it provides the best end-to-end experience. You can use other tools, they're very good maybe at generating a specification or generating certain code, but for what we're doing, this is a good experience.
And I can't stress just how much using NSWAG to generate code has changed my life. Like it really is a huge amount of time off. Even if it takes you a couple of days to get it to work first time round, it's worth investing that time because you can cut some development time in half. There's so much double handling that disappears, and you've got so much freedom to then change things because you know you can generate the second half. If you have to rewrite client side and server side to make a change, you're going to be afraid of changing things, and you're going to sit there and live with an API with names that don't really line up, but you're too afraid to change them, which makes it harder to understand in the future. Being unafraid to just change things around means you get a much easier to understand situation in the future. Once you've finished playing around with NSWAG Studio and you can edit, take that config file, it will just run on Macs. It's just that UI program that we used to click through and set up. But once you've got that specification file, and you can, once you know their settings, just create the same JSON file for the settings.
It's been built in WinForms, I think. We really should be rebuilding that. That could be a very valuable contribution. Oh, the base URL? Yeah, it depends on the client app that you're building, but generally you build that into the configuration. So let me think. I have a good example for that. Northwind Traders. So if we dig into the web UI here, the client app, and source, I think. Did I go too far? Maybe too far? No, it's in environments. Environments. And you can see I've got an environment here, environment.ts, and I've got a base URL specified there. So that's my development base URL. And then in my prod one, which is going to be used when Angular does its prod build, I've got my live site there. So yeah, configure it there, and then yeah, you can generate your specification, your clients, and that at development time, and check it in as normal code. It also means that other people in the team don't have to worry about that whole nswag process so much. You can set it and forget it.